Okay, we're back. And now within the world of variables, let's focus on independent variables. So an independent variable we oftentimes refer to as an IV. I often have students thinking that that's the Roman numeral 4 on the screen. It's an IV, and it is named after the concept that the independent variable has groups that are independent of each other. You're either in the experimental condition or in the control condition. There is no overlap. So the independent variable has independent groups. So an easy definition of the independent variable is it's the variable or variables in a study that the experimenter purposely manipulates. It's really important to say purposely, because there are other variables that might be happening that the experimenter doesn't have control over. We'll talk about those later. But what we're talking about here, the independent variable, the experimenter is purposely manipulating that. So giving you different reward schedules, or giving you different kinds of punishment, or allowing rest periods or not, or administering some kind of drug or not, giving different kinds of instructions to the experimental group versus the control group, giving a different task to perform. These are all examples of things that the experimenter can manipulate. The whole reason for doing the study is to discover the effect of the independent variable. Like, that's the whole reason why we're doing it. Does this, the IV, cause that, the DV? That's what we're trying to figure out. So independent variable is absolutely the purpose for conducting the study. All right, let's talk a little bit about the different types of independent variables. This is not a comprehensive list of things that people can use as independent variables. These are categories of things that people can use. So for example, there are the physiological independent variables. This would be things like anything that manipulates the physiology of the participant, the physiological state of the participant. So for example, if I were to administer caffeine pills to the experimental group and sugar pills to the control group, and not tell anybody who's getting what, the person who received a caffeine pill might start feeling a little edgy and not know, oh, I took a caffeine pill. So they're like, oh, am I experiencing stress? Am I nervous? Am I feeling jittery? So we can use something like a drug to change the physiology of the person so that then we can move on with whatever else we're doing. So physiological, this would also include research where we deprive people of sleep, for example, or we wake them up every time they go into REM sleep. Like that would be another example where we're with the purpose of depriving them of something physiological like sleep, right? So that would be an example of a physiological. Now with experience, we're going to manipulate the amount or type of training or learning or whatever their experience within the experiment is. So we're manipulating what they're seeing or doing or hearing. So a good example is giving the instruction to rate words for pleasantness or to check whether the word contains an E. Those are examples of an experience that they're having and that I have control over as the researcher. And then there's situational independent variables, and that would be where we're doing something to the environment. Something is different. It could be the temperature in the room. It could be the amount of lighting in the room. It could be the color that the walls were painted. It could be noise. It could be all sorts of things, right? So the example I've got here is, low levels of lighting versus high levels of lighting on an assembly line. We could have an impact on their situation and see if that affects their productivity, right? So in all of these cases, we're manipulating something so that we can then measure whether that something is having an impact on the dependent variable. All right, so this all gets us to the simplest. So I mentioned the KISS protocol. I just have now defined the independent and dependent variables. Now we are to the two-group design. This is where you have one independent variable with two levels. Now in experiments, levels are known as conditions or groups. When we get a little farther on, we'll start calling them factors. The two levels would typically, the one is called the experimental group, and that's the one that's going to receive whatever your independent variable is, and the control group that's going to get some kind of inert or non-existent or sham independent variable. That's traditional experiments. Psychology is not so great for having true experimental and true control groups, even in experiments. A lot of times it's that the experimental group is getting the new thing that you're trying out, and the control group is getting maybe the old thing that we already know how well it works or not. So for example, maybe we're trying out a new treatment for depression. And so the experimental group gets the new treatment for depression, and the control group gets the standard cognitive behavioral therapy or something like that. So sometimes it's kind of hard in psychology to tell, which is the experimental group and which one's the control group, and we'll get back to that a little bit later. The simplest controlled experiment is this kind of two-group design, where you just have one manipulated independent variable, and you want to see whether the two groups score differently on the dependent variable. That's the simplest thing you can do. And as much as we possibly can, we should strive for this. If we can use this kind of design, it's the simplest one, it's the most powerful one to tell whether two groups are different from each other or not after the treatment. So I do a jelly bean experiment in my live classes, and so I ordered from Jelly Belly 2 bags of jelly beans because I thought they looked pretty similar to each other. You know how Jelly Bellies can be, they have lots of markings and stuff on them a lot of the time. So this very cherry jelly bean looks very similar to the Jelly Belly Tabasco. Like they're pretty similar as far as like the gradations. When you have them in real life, you can tell there's a slight metallic look to the Tabasco one that's not there for the cherry. And then obviously when they're side by side, you can see that the Tabasco is a little bit like redder red, and the cherry one is a little bit more leaning yellow, I guess, towards orange. But the same person's not holding both of these. So it's enough that if you're looking around and you can see that everybody has a red jelly bean, you're kind of under the impression everybody's got the same flavor. And so I pass out the Jelly Bellies, everybody gets one, and then they get this little rating paper here. So they're supposed to, for whatever reason, I have them write down their age and then have them circle their sex. It doesn't matter. And then I have them rate the degree to which the flavor of the jelly bean met your expectations. So verbally, I say to them, look at your jelly bean, examine your jelly bean, think about what you think it's going to be. Like make a prediction in your mind what flavor you think this jelly bean is going to be, and then eat your jelly bean, and then complete this little rating scale. And there's, 1, it doesn't at all represent my expectation, to 5, it perfectly met my expectation. So it's a little 2-group experiment. You've got the ones who got the typical flavor of jelly bean, which is the cherry one, and then you've got the ones who got the atypical flavor of jelly bean, which is the Tabasco one. Did they rate their jelly beans differently as far as how much the jelly bean met their flavor expectations? So my last class that I did this with, I compiled the data. And so up here in this first little table, you can see that, I've got the experimental and the control group. I sort of arbitrarily assigned the experimental group as the atypical flavor because, it's not common to get Tabasco flavored jelly beans. So I thought that would make sense that it's the experimental group. And then the control group got the typical flavor of jelly bean, which is cherry. And then the dependent variable is the rating of the flavor expectation. How well did that flavor meet their expectation? And then I made a graph out of the results so that you can see the rating of flavor meeting expectation from 1, not at all, up to 5. And then the atypical is in the lavender and the typical flavor is in the buff color. And we can see that the atypical is about as close to the floor as you can get. The 1 is the lowest rating and they are just barely above 1. Whereas the group on average is around 3.5 out of 5, something like that, maybe a little bit more than that. It's important that I'm emphasizing these numbers because what we're doing in a 2-group design is we're going to compare the mean rating score. We're not going to look at any one person's individual rating. Maybe there is somebody in the atypical group who has seen Tabasco flavored Jelly Bellies before and accurately recognized it and said, yep, that was Tabasco. I'm giving it a 5. It's exactly what I expected. It's possible that there was somebody like that in there. It's possible that, you know, the person thought maybe it was cinnamon and came to the conclusion that it was close enough that it was a weird flavor, and so they gave it a 2 instead of a 1, something like that. It was kind of what I thought. I thought it was going to be a weird flavor. So individuals may have given something different than what most people did, which was a 1. It didn't meet my expectations. But all we're interested in is the group average, and same thing for the typical, right? Some people maybe thought it was going to be cinnamon and got a cherry, or maybe some people thought it was going to be watermelon, or who knows, and so they were like, oh, not quite what I thought it was going to be, but pretty close. As I scored these, it was like mostly 5s and mostly 1s in the 2 different groups, let's just be honest, but there were people who varied. And those people who vary, they affect the mean, but we don't go, oh, well, all of these other people are wrong because one person gave the cherry flavored jelly bean a 1. Like, you don't do that, right? You do the averages. And so that's what's meaningful in these 2 group designs, is that we want to see what the average is for each of the groups, and do those 2 groups differ? And I can tell you the statistic that I ran, and I'm not going to show you or whatever, but I did a t-test, and absolutely significant difference between these 2 groups as far as their mean rating. So that's how you sort of would set up a 2-group experiment and make those comparisons. All right, let's go ahead and take a break, and we'll come back and talk about participant characteristics.